The black tiger shrimp is one of the two main cultured shrimp species in Vietnam. Its advantage is an indigenous resource that can be farmed and exploited for a long time. With its significant size, delectable flesh, and high economic value, black tiger shrimp is in demand in many countries for export. According to statistics from the Vietnam Directorate of Fisheries 2020, the area of saline and brackish water shrimp farms reached 720,000 hectares, yielding a total output of 750,000 tons. As the commercial shrimp farming industry expands, there is an increasing demand for broodstock that is disease-free, fast-growing, and disease-resistant. However, this remains a significant challenge not only for Vietnam but also for many other countries in the region and worldwide. Our country prioritizes the sustainable development of black tiger shrimp production, focusing on minimizing the ecological impact by establishing natural broodstock resources through breeding programs that enhance survival and growth. In the following section, we will explore the black tiger shrimp and its production process. The black tiger shrimp, also known as the giant tiger prawn in English, has a scientific name of Penaeus monodon, Fabricius, 1798. The black tiger shrimp, classified as Penaeus monodon, is widely distributed in the Indian Ocean, Japan, Taiwan, East Tahiti, Southern Australia, and West Africa. Postlarvae and juveniles live near the coast and coastal mangroves. As adults, they move away from the shore because they prefer to live in deeper water. Shrimp body color can vary diversely depending on the water layers, feed, and water turbidity. They are light reddish-brown or dark brown when grown in the sea, dark gray or black in areas of rivers, mangroves, and other brackish water, or sometimes pink or red. Black tiger shrimp are active and tend to eat more at night. During the maturation stage, they bury themselves in the pond bottom. As omnivores, they primarily feed on other animals, including crustaceans, polychaetes, and aquatic plants. Their feeding behavior and diet vary depending on each growth stage. Like other species of Penaeidae, the whole body of black tiger shrimp is completely covered by an exoskeleton and divided into many segments. These segments are connected by motion segments. From the outside, the structure of black tiger shrimp consists of two parts, the cephalothorax and the abdomen. The cephalothorax covered by a large cephalothorax is called the carapace. Above the blade-shaped, serrated rostrum of the black tiger shrimp are 6 to 8 teeth, while below are 2 to 4 teeth. Their heads have an olfactory system and two pairs of antennae, A1 and A2. These are the organ that helps shrimp recognize and keep balance. The abdomen consists of 6 body segments and a tail segment. Black tiger shrimps fall under the Decapita order, with 5 pairs of walking legs, periapod, under the head and 5 pairs of swimming legs, pleopod, under the abdomen. Their tail has a pair of uropods that function as a paddle wheel for swimming and jumping. The digestive organs of shrimp include: stomach is used to store and grind food. Hepatopancreas, also known as the midgut gland, synthesizes and secretes enzymes to digest food. In addition, it is also a place to absorb and store nutrients. Feed is digested in the intestinal tract of black tiger shrimp, located beneath the hepatopancreas and extending to the tail. The anal is located at the end of the intestinal tract. Black tiger shrimp exhibit sexual dimorphism, with females generally larger than males. They can reach up to 33 centimeters in length, and both genders mature from the 8th month onwards, with distinguishable external sex organs. Shrimp have two sinuses in their eye stalks that secrete hormones inhibiting egg maturation, GIH, gonal inhibiting hormone. Shrimp eye stalk ablation is a procedure that removes or reduces inhibition, promoting faster maturation. However, bilateral eye stalk ablation tests have resulted in shrimp death. Unilateral eye stalk ablation is a successful technique for stimulating sexual maturation of black tiger shrimp in Taiwan for the first time in 1977. However, a non-ablation eye stalk method is becoming increasingly popular in replacing the traditional approach. According to the study, Lidopenaeus vanameae broodstock reproductive performance and quality without cutting eyes under commercial-scale farming conditions, conducted under the SEAT project. Commercialization of the EU-funded Ethical and Sustainable Aquaculture Sector, 2009 to 2014. The results showed that shrimp without eye stalk ablation produced more eggs. Moreover, the nauplii had a higher survival rate than those from eye stalk cutting broodstock. Bình Minh uses the eye stalk non-cutting method on Lidopenaeus vanameae and is researching its application on domesticated Penaeus monodon to meet international animal welfare standards. Determining male maturity in black tiger shrimp is challenging. Farmers rely on weight, with males weighing 50 grams or more considered mature. The sex organs are located under the abdomen, with petasma for males and thelycum for females. The thelycum group, found within the marine shrimp family, can be divided into open and closed groups with different mating characteristics. Penaeus monodon belongs to the closed thelycum group, which means that the female only mates after finishing molting. Their reproductive process involves molting, mating, maturing, and laying eggs in that order. The spermatophore of male black tiger shrimp is transferred to the female's thelycum during mating. This led to the development of the spermatophore extrusion technique for Penaeus monodon in Taiwan in 1984, now used to breed various shrimp types. The molting process of Penaeus monodon takes place prior to mating. Let's watch this process. The steps in the mating process are described as follows. The male is initially attracted to the female and makes contact from behind, with his rostrum touching the underside of the female's tail. They may then chase each other or swim side by side, with the male typically swimming below and behind the female. The male then approaches the female from below, aligning their heads and abdomens. The male then switches perpendicular to the female, shaking the head and tail a few times to transfer the spermatophore to the female. Fertilization occurs when the eggs pass through thelycum and come into contact with sperm. Shrimp are typically spawned from 3 to 7 days after eye stalk ablation. Female shrimp lay their eggs at night, usually between 8 p.m. and 2 a.m., and the spawning process usually lasts 2 to 7 minutes. Before laying eggs, female shrimp rest on the tank bottom, but become active when spawning, swimming and jumping. They then release eggs into the water, using their swimming legs to disperse them evenly. The number of eggs produced per spawning event ranges from 300,000 to 1,200,000 for wild females weighing 100–300 grams. If the eye stalk is removed and the female is raised and stroked in a cement tank until maturity and egg laying, she can produce a quantity of eggs ranging from 200,000 to 600,000. To complete their life cycle, shrimps undergo several stages, including egg, nauplii, zoea, mysis, postlarvae, juvenile. The eggs hatch into nauplii within 12 to 14 hours at a temperature range of 27 to 28 degrees Celsius. As shrimps grow and increase in weight and size, they must undergo molting to continue their development. The stages of growth for shrimp include: nauplii consists of 6 stages. The nauplii swim in short bursts and then rest. Molting occurs 4 times, with each molt taking about 7 hours. They live on yolk sacs, requiring no external feeding. Zoea consists of 3 stages, swim continuously near the water's surface, and have strong phototaxis. They molt twice, with each taking around 36 hours, and are filter feeders, mainly consuming phytoplankton with a size range of 3 to 30 micrometers. Mysis consists of 3 stages. The mysis swim downward with their tail leading and their head following. They mainly feed on zooplankton. After the mysis stage, the larvae enter the postlarvae stage, a stage close to adulthood. Postlarvae have a similar shape to adult shrimp and gradually begin to live on the bottom. Juvenile, the adult stage. Limited availability of natural broodstock resources due to seasonal and reproductive habits has led to an increased demand for postlarvae and commercial shrimp in Vietnam. Effective selection and nurturing techniques of broodstock are essential for high productivity and reproductive efficiency in shrimp hatcheries. The selection criteria are quite similar to those used for other typical aquatic species, as follows. 1. Females are selected if they weigh at least 150 grams, while males must weigh at least 120 grams. 2. A well-proportioned body with large size and bright color, clean body and gills, and intact appendages without abrasions or injuries or parasites. 3. Shrimp reach reproductive maturity at stage 4, with intact thelycum for females. Its thelycum has no black spots on the outer surface. The male has an unbroken or uncompressed petasma. 4. Optimal levels of reproductive capacity and broodstock health are necessary for successful breeding of future generations. 5. The broodstock is selected based on good traits after being chosen and crossbred from different shrimp lines around the world. 6. They must be disease-free and tested negative for various viruses and bacteria, including white spot syndrome virus, yellow head virus, monodon baculovirus, hepatopancreatic parvovirus, hepatopancreatic necrosis disease, infectious hypodermal and hematopoietic necrosis virus, luminous bacteria disease, and black gill disease. Moreover, EHP is also a significant problem. Broodstock must be tested negative PCR results for EHP before breeding. 7. Healthy broodstock should exhibit normal feeding behavior, fast swimming, and quick responses to sound and light stimuli. They should swim backward rapidly and continuously when the water is disturbed. Minh always prioritizes selecting reputable and leading broodstock suppliers with clear traceable origins that meet all the standards for broodstock selection, ensuring the delivery of high-quality postlarvae to farmers. Before introducing broodstock to the farm, it is crucial to perform full hygiene and domestication procedures to ensure biological safety. The bags containing the broodstock must be disinfected with an iodine solution, 500 ppm, and rinsed in a clean water tank. Broodstock should be placed in a quarantine tank having water parameters with similar temperature, pH, and salinity levels to water in the transport bags. When the temperature inside and outside the bag has been balanced, open the bag and fill it with water from the tank. Then, use a net to scoop the broodstock out of the bag and stock them into the nursery tank. The stocking density should be 2 to 3 shrimps per cubic meter with a male to female ratio of 1 to 1 or 1 to 2. After approximately 4 hours of stocking, the environmental factors should be gradually adjusted. In addition to the quality of the broodstock source, an optimal living environment is also a helpful factor for the reproduction process. The temperature, salinity, and living space in the farming tank should be similar to the marine environment of the shrimp. Optimal water conditions for broodstock: tank temperature 27 to 28 degrees Celsius, salinity 30 to 33 ppt, pH 8.0 to 8.2, NH3 and NO2 less than 0.1 ppm. Any shrimp with symptoms such as black spots on the body, large white spots on the muscle, or red body and gills should be immediately removed to avoid infecting other shrimp in the batch. In addition, hygiene is also an important issue that needs to be focused on. Poor hygiene can seriously affect production due to issues such as bacteria, algae blooms, solid waste accumulation, fungi, and many other disease-causing microorganisms in the culture system. Regular tank siphoning and removing excess feed with a shrimp net help maintain a clean environment for the broodstock. Dead shrimp or molted shells should be removed from the tank every day. At the same time, 100% water should be exchanged in the morning. Reuse water by circulating it through the filtration system after changing. To have mature broodstock, in addition to good reproduction and larva quality, feed is one of the decisive factors. Providing a complete and balanced diet is essential to ensure that there are adequate reserves in the yolk sac for normal embryonic and larval development. Live organisms such as squid, polychaetes, oysters, and artemia are commonly used in the diet for broodstock. However, using them can be challenging as it requires a lot of labor for processing, storing, and quantifying. In addition, they have low biological safety, which causes water quality issues and increases disease risks. Furthermore, their cost can be high, and their nutritional value may vary by season. The quality and quantity of nauplii produced by female broodstock are influenced by the type of feed, feeding ratio, and freshness. Typically, broodstock are fed about 30 to 50% of their body weight per day on a fresh weight basis. Feed quantity depends on mating frequency and shrimp health. Adequate feeding is crucial to prevent pollution and reduce disease transmission risk. Feed for live shrimp needs to be processed before use. Thorough washing and treatment of live feed is essential to prevent pathogen transmission to shrimp. Research on culturing and producing specific pathogen-free, SPF, polychaetes is ongoing to provide disease-free feed for shrimp, which does not rely on natural polychaetes. Applying heat or freezing treatments can be effective in eliminating or reducing the occurrence of major shrimp diseases, particularly those caused by bacteria associated with AHPND or EHP spores. However, numerous studies have shown that live feeds do not provide sufficient essential nutrients, particularly vitamins and minerals, to support the maturation and reproduction of shrimp. Therefore, to ensure nutritional balance, Bình Minh has added supplementary feeds, natural and synthetic vitamins, and natural astaxanthin to enhance reproductive capacity, lower stress levels, and avoid physical harm during subsequent reproductive cycles. Hatchery technicians need to master both basic biological characteristics and technical requirements for larval rearing tanks, natural food production, and water source treatment. There are some issues to note, including collecting nauplii, managing water quality and shrimp health, and providing proper larval nutrition. Stop aeration after larvae develop to stage 3-4, as positively phototactic larvae will float to the water surface. Select high-quality larvae based on strong swimming towards light, complete appendages, no deformities, and a grayish-white color. Water quality indicators need to be maintained stable, including temperature 29 to 33 degrees Celsius, salinity 27 to 31 ppt, pH 7.9 to 8.2, and KH 110 to 120. Temperature should be measured twice per day, and it must comply with the production process. If it falls below the standard range, use the heating device to increase water temperature. Air nozzles should be arranged and controlled for each stage of the larva. Regular health checks are crucial to detect and address any potential issues early on, contributing to improved production efficiency. These checks should be conducted in the morning to make necessary decisions regarding water changes, temperature adjustment, and diet. Aeration should be turned off during siphoning. There are 3 levels of shrimp health inspection, including 1. Observation to check shrimp health, water status and feed usage. 2. Examination in the laboratory by observing under a microscope and cultivating microbiology. 3. Using more advanced technologies such as PCR techniques, rapid tests, and other immunological methods to detect virus diseases. Just like the role of nutrition for broodstock, feed for shrimp larvae is also an equally important factor. The development and survival rate of larvae, as well the quality of the culturing water depend heavily on feeding and the quality of feed provided. Thus, providing high-quality nutrition is essential to ensure the best possible conditions for their growth and survival. A variety of feed types are available for different stages of the larva's life cycle, including fresh and dried algae, commercial and processed feed, and artemia. During the nauplii stage, the larvae use nutrition from the yolk sac, so they do not require external feeding. Gentle and consistent aeration is crucial to prevent sinking, and regular observation is needed. When the zoea larva stage begins, feeding can begin. The best feed for zoea larvae is pure live algae species, Chaetoceros, Thalassiosira, or Skeletonema spp. Feed zoea larvae 4 to 5 times per day and maintain regular algae density in the culture tank as they are continuous filter feeders. If live algae is not available, dried algae or commercial feeds in emulsion or dry form, in particle sizes of 10 to 80 micrometers, can be used as supplements for zoea 2 to 3. It is important to regularly monitor zoea tanks to ensure that the larvae always maintain their long tail, which is a sign of healthy zoea and adequate feeding. Bình Minh has an in-house algae production area to ensure a constant supply of high-quality algae for their farms, and the harvested algae is distributed based on the farm's requirements. From the mysis stage and onwards, these larvae have the habit of actively feeding, so they are fed with artemia. Synthetic feeds can be supplemented alternately with artemia, feeding about 6 to 8 times per day. Bình Minh prioritizes the use of Vinh Chow artemia, a highly nutritious and top-quality artemia recognized worldwide, providing optimal nutrition for the shrimp larva. After receiving from the store, artemia will be rinsed with water for 30 seconds, then divided into hatching tanks. The temperature is maintained within a stable range of 28.5 to 31 degrees Celsius. Artemia hatching requires a strong light intensity and moderate aeration, with an average density of 2 grams per liter and a hatching time of 18 to 20 hours. Rinsing with clean water is necessary before distribution. Post-larvae care involves providing enough feed and ensuring they are adequately fed to prevent cannibalism. Artemia and synthetic feed are the main foods, and water changes should be done frequently. Harvesting can be done when the post-larvae are 13 to 15 days old. It is necessary to note the feeding ratio and dosage should be based on observations of the larva's feeding habits and water quality, as well as the recommendations and experience of the manufacturer. Slow and careful handling during harvesting and transportation helps to minimize stress on post-larvae, leading to high survival rates and faster growth in shrimp ponds. Before being delivered, post-larvae need to be inspected for quality, length, and the development of their liver and disease according to Vietnam's and OIE's industry standards. After reaching the company's quality standards, they will be packaged, shipped, and transported by specialized refrigerated trucks to the farmers. Healthy and flexible post-larvae are acclimated and cooled during transportation to minimize loss and ensure their quality upon arrival at the shrimp pond. Farmers need to follow the technical team's guidance or refer to instructional videos to acclimate the shrimp and achieve a high survival rate when stocking them.
Above are some insights into the black tiger shrimp and the process of producing post-larvae. It can be said that producing quality post-larvae delivered to farmers is not an easy task. It must go through many stages, many processes with rigorous techniques. Therefore, Bình hopes that this video has provided useful information and knowledge for farmers to better understand black tiger shrimp in general and the domesticated black tiger shrimp in Pacific, helping to make more accurate decisions in selecting post-larvae, contributing to a successful farming crop. For any inquiries and contributions, please contact us at 1900 866869. Thank you.